Hello everyone. The next preparation method of phenol is decarboxylation of sodium salicylate. Already we have discussed the three preparation methods. Now it's the time to understand fourth one. First of all, we need to understand the meaning of decarboxylation. Decarboxylation means D means removal. Of carboxylation means carbon dioxide gas. If carbon dioxide gas is removed from any molecule, we will call it decarboxylation. Whose decarboxylation we have to do? We have to do decarboxylation of sodium salicylate. Now let's check what that reaction is. Mechanism not in a 12th class. For JEE, NEET and BSc, mechanism part will be there. First, that reaction is this is sodium salicylate, benzene ring connected with OH. On a ortho position of OH, COO negative sodium, this group is attached. Oxygen sodium is making ionic bond with each other. So when you will react it with CaO plus NaOH and heat it, this combination is very important. This combination is known as soda lime, in which sodium hydroxide and this calcium hydroxide is mixed in 3:1. Like 1 ratio will be of calcium oxide and 3 ratio will be of sodium hydroxide. This special reagent is used for removal of carbon dioxide gas. For removal of carbon dioxide gas. I will talk about it separately in a mechanism. In the presence of this soda lime, on heating, this molecule will eliminate its carbon dioxide gas. CO2 gas you have to eliminate out. And firstly, this will generate sodium phenoxide. Sodium phenoxide. Actually, this O and H, this O and benzene ring, this part is known as phenoxide. Phenol, as you know, this is phenol. So when you will remove this hydrogen from it, electrons will transfer toward oxygen and it will carry a negative charge. In this condition, it will become phenoxide. So phenoxide is stabilized by sodium, +1 on sodium, oxygen is -1, ionic bond is there. So this salt is known as sodium phenoxide. So this is the first step of the reaction. First sodium phenoxide will generate. This is white crystalline solid, sodium salicylate. This is white powder, soda lime. On heating, they are going to create sodium phenoxide, which is also a white color substance. Now in second step, very easily we can convert it to phenol by doing hydrolysis with the help of dilute HCl, as we have done in last preparation method. So dilute HCl, you know, dilute condition means water molecules are there. Water molecules are going to provide us H positive, OH negative. Here you just need to take care of charges. It is negative, it is positive. Now just positive you have to connect with negative and negative you have to connect with positive. So phenol will be generated out like this, OH, and side product will be NaOH, which will be neutralized by the acid. So NaCl and H2O, they will generate out. Now this is the reaction which students have to learn up to 12th class stage. So learning technique, you just have to cram, but soda lime, you just have to learn. Soda lime is a carbon dioxide removal, CO2 removal. Just learn it. And sodium salicylate formula you have to learn. Carbon dioxide gas you will release out, this one. Now, when this gas will release out, you can check how this carbon dioxide, when I will tell you the mechanism, automatically everything will be understood. You just need to release out carbon dioxide gas, sodium phenoxide, and from sodium phenoxide very easily you can learn this reaction, dilute HCl, hydrolysis condition it is, H positive, OH negative ions will be there, H positive on a negative particle, OH on a positive particle. Phenol will be generated. So these are the two steps in which these reactions are getting completed. Now let's go for the mechanism. In mechanism, we should understand soda lime first. Like what is soda lime, how to make it? It's a combination of calcium oxide plus NaOH, white crystalline solid of calcium oxide, white powder, actually it will be in white powder form, white crystalline pellets of sodium hydroxide, they will be mixed, and little bit water we have to add here. So this combination will create, as CaO will combine with water, it will create CaOH twice, calcium hydroxide, and NaOH will remain as it is. We will dry it, so we will have a white color solid substance, white color solid particle, which will have holes or voids in it. That's why it is known as porous soda lime. Porous means pores are there, voids are there. In those voids, it can absorb carbon dioxide gas very easily. Now, let me tell you what reaction will happen with this soda lime and carbon dioxide gas. As you know, in soda lime, water molecules are available. So carbon dioxide gas plus water firstly will create carbonic acid, H2CO3. This one. How you can solve this reaction? Water molecules, as you know, will break in two parts, H positive, OH negative. Carbon dioxide gas, you know, carbon is carrying positive, oxygens are carrying negative. So this OH negative will attack on this positively charged carbon. Obviously pi electrons will shift toward oxygen, and these electrons, as both electrons are going toward oxygen, so this carbon is losing its electron, but its valency will be satisfied by this OH negative, in which oxygen is going to deliver its electron to carbon. This one. These three pairs are there, it will deliver. So pi electrons will shift toward oxygen. Oxygen will carry complete -1 charge, which will be filled by H positive. So after this attack, we will have this one, carbonic acid, H2CO3. In this fashion, carbon dioxide is creating carbonic acid. So CO2 absorbed on the surface of soda lime will react with water molecules first. H2CO3 will generate. Now this is acid. It is a acid. This acid will react with base present in soda lime. Which base is present? Sodium hydroxide is present. NaOH. Obviously will react to create what? Let's balance it. Sodium carbonate will generate, acid base reaction, normal acid base reactions, 2H2O will generate if you will balance it. Acid H positive, it's a negative part CO3s. In base sodium positive, OH negative. So this OH negative is going to combine with H, water molecules will release out. Na positive will combine with CO3, Na2CO3, salt will generate this one. To balance it, we need this much. So you can check the water molecule which was finished in a limestone, in soda lime, it is regenerated again. One particle was finished, two particles are generated. Means amount of water molecule will remain same there. Now, this sodium carbonate will finally react with calcium hydroxide, which was generated. As I told you, in soda lime what is happening, calcium hydroxide was there. Now this calcium hydroxide is going to react with sodium carbonate. So very easy reactions, they are up to 10th level we have already done these reactions. Positive and this is negative. This calcium is positive particle, OH is negative particle, so you just need to combine them. So what you will find out, CaCO3 will generate, calcium carbonate will generate, and two particles of NaOH will generate. Means if overall we check, two NaOH were utilized, sodium hydroxide molecules from soda lime were utilized, and they are regenerated again. So there is overall no loss of sodium hydroxide during this reaction. Carbon dioxide you can check, it is converted itself to calcium carbonate. Only there is a loss of these sodium carbonates, calcium hydroxide. These calcium hydroxides are overall getting lost. Water molecules which were used, again they are regenerated. So this is happening on the surface of soda lime. Carbon dioxide is absorbed on the surface due to voids in it, and after that these reactions are happening. These three reactions are happening. Now let's go to our main organic mechanism. First step, very easy. This sodium salicylate on heating with soda lime. As you know, soda lime have a power to absorb carbon dioxide gas. So it will start absorbing carbon dioxide gas from sodium salicylate. And how carbon dioxide gas will generate? Check. This oxygen carrying -1 charge will shift these electrons toward carbon, and these electrons which are here between carbon, they will be shifted toward this carbon like this. So in this fashion, when this carbon will lose its electron toward this carbon, vacant orbital will generate here. That vacant orbital will be filled by lone pair. So between these carbon and oxygen, double bond will generate. So finally from here, what will release out? CO2 gas. This one, which will be absorbed on soda lime. How? Already I have told you the three reactions. In that fashion, it will be absorbed on it. Now, this particle will turns to a carbanion, negatively charged. This carbon will have lone pair and negative charge will come. How this negative charge will be satisfied? Please check. And what about this sodium? Obviously, it will break bond from this oxygen because oxygen is making bond with this carbon. So Na positive will be released out from here. Wait, check what will happen with this. Okay. Oxygen is connected with this hydrogen. This hydrogen is carrying high positive charge because you know it is connected with oxygen, and oxygen is highly electronegative. It is absorbing electrons toward itself very strongly. So high positive charge is there on this H, and this positively charged H will come in the contact of this carbon, and obviously it will attach with it because it is a negatively charged carbon and it's a positive hydrogen. Between oxygen and hydrogen, bond will break and this hydrogen will join with this carbon. So check. Hydrogen was released as H positive without electron, because when bond will break, both electrons will shift toward oxygen, due to which oxygen will carry a extra negative charge. Already it is carrying two pairs. I have not drawn, draw by yourself. Okay, I am drawing. And this hydrogen will have a vacant orbital when it will release out with a positive charge. The vacant orbital of this hydrogen will be fully filled by this lone pair. Now this lone pair, in this lone pair, the carbon was carrying one extra electron. That extra electron it will provide to this hydrogen, so its negative charge will also finish. Means the positive charge of hydrogen will finish and the positive negative charge of carbon will also finish. This sodium will stabilize this. So finally what we are getting? This sodium phenoxide, positive charge on sodium and a negative charge on oxygen. This is the first step. Now in second step, very easy reaction is happening. Let's understand. This was the first step. Nothing too much to understand in the second step. Sodium phenoxide, which is generated over here, in sodium phenoxide, oxygen is carrying -1 charge and sodium is carrying positive charge, and we are reacting it with dilute HCl. In dilute HCl means lot of water molecules are available. Water molecules will break in two parts, H positive, OH negative. With the help of H positive and OH negative, we are going to break bond between oxygen and sodium. So means we are doing hydrolysis. So that's it. H positive will attack on O negative, OH negative will attack on Na positive. So there will be a generation of OH, phenol. Na will combine with OH, which can be further balanced by HCl or diluted by neutralized by HCl in the form of acid-base reaction, NaCl and water molecule, NaCl plus H2O. That's it. This is the overall reaction we have for the generation of phenol with the help of sodium salicylate and soda lime. Please check the work of soda lime properly. Soda lime is a white crystalline solid which have pores in it. Pores means voids are there. With the help of those voids, it absorbs carbon dioxide gas, and further 3 reactions will happen which are given in a video. Thank you very much for watching the video.